Hello everyone, we're going to be looking at language of statistics today. So I'm going to introduce you to some terms that you may or may not be familiar with, but are used when we're talking about evaluating statistics, looking at statistics, and making conclusions based on statistics. So there's quite a few words to get through, but the first thing I want to point out is that a statistic can be defined by a fact of data or a piece of data that is from a large numerical survey. Generally, and you can probably link to this, but people in health organisations or people who look at market research, for example, will go out and they'll survey quite a few people. They'll ask them a few questions, and then from that they will construct maybe a conclusion, like 60% of people like watching TV or something like that. That would be an example of a statistic, because essentially it's a summary or a fact based on some data that people collect. And there are quite a few different ways we can actually have statistics. There's quite a few different things we can get from numerical information. And sometimes it may not necessarily be numerical, but it may also be categorical as well. But it's a large survey, it involves quite a few people, and we generally get some sort of conclusion from it. Sometimes it can be opinion-based, sometimes it can be based on their habits, that kind of thing. Okay, so now that we've sort of defined what a statistic is, we'll have a look at the concept of quantitative and qualitative, or generally, quantitative and categorical. So, quantitative, and you can probably see a word in here, quantity, or the beginning of the word quantity there, and that makes you think numerical. And that's essentially what this type of statistic is. Quantity means numerical. You think of a number when you think of a quantity, and from that we know that there's going to be some numbers involved. Now, quantitative generally has two types. We have discrete, and we can have a sort of range when it comes to quantitative data. So discrete means that it has to be a full numerical answer. It can't be part of a range. So if I were to give you an example, a discrete quantitative statistic would be your score out of 10 on a test, for example. Presuming that you don't get half marks as well. But that could generally take the numbers 0, 1, 2, 3, 4, all the way to 10. And it's discrete, so you can't have half marks, you can't have anything like that. You generally get a whole integer. Another example is the number of people living in your household. It can be, well, there can't actually be 0 people living in your household, but we can have 1, 2, 3, 4, I don't know, it may go on. Some people have quite a few people in their household. But again, that's another example of discrete, because you can't actually have a portion of a person. Well, at least probably not legally. So in terms of a range, we could think about how much water's in a water bottle. And generally, if it was a 500ml water bottle, it would be anywhere between 0 and 500 mils. And from that, it could maybe be 472.4 millilitres, or 471.57 blah 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 millilitres. And as you can see, it's part of a range there. It's not limited to just whole integers, because we can have portions of millimetres as well, depending on the precision of our measuring instruments, of course. But that's just to look at quantitative data there. I know I sort of glossed over it reasonably quickly, but essentially it's a numerical answer, and from that we're able to generally construct things like means and standard deviations from quantitative data, whereas categorical data, which I'm about to go into, we generally don't have means and any sort of standard deviation. So categorical data, which is the other type of data that we can have, essentially, as you can probably tell from the name, relies on different categories, and generally can't really construct any idea of spread to some extent, unless you have a look at the frequency of some categories. But categorical data is purely where you survey someone and they give you something like, maybe it's a colour, red, or maybe black, blue, but they don't give you a numerical result. And the question might be, what colour is your car? And you might say red, black, or blue. Now, unless you look at frequency, then from that you can't really draw any sort of conclusions about the mean or the spread of data. But think categorical as in category. And again, think of it as not being, there's no sort of scale between it. We can't say that red's 1, black's 2, blue's 3, because they're all different colours. They're not related to each other. And because they're not related, we can't do a distribution for it. There's no sort of mean, because these aren't a spectrum as such. But that's a look at categorical data. It focuses on non-numerical answers with statistics. So a conclusion you could draw from this is most people have a black car, maybe, or something like that. So that's categorical data, and as I said, we can't compute quite a few things numerically, because of course it's not working with numbers. Okay, so we've had a look at a few properties of single variable statistics. Now let's have a look at the next one, and that is the mean. And you've probably heard the word average before as well. That's essentially what the mean is. It's the average value. So the mean is denoted by x bar equals the sum of our data set over n, where n is the number of numbers within our data set. So if we wanted to compute the mean for 2, 3, and 5, for example, x bar would equal the sum of those numbers, 2 plus 3 plus 5, all over n, and n would of course be 3. So that would be 2 plus 3, which is going to make 5, plus 5 is going to be 10, so it's going to be 10 over 3 is our mean. Okay, and that's what the mean essentially is. You've probably calculated quite a few times before, so I probably won't go into it too much, but again, think of it as the average, and generally in a distribution you will have a mean value, and then you'll have standard deviations. Okay, so moving along, and the next M word, because there's 3 of them that are generally used in statistics, is median. And that is the middle number, essentially. Okay, so with the middle number, what we do in order to find it is we find its position, and we do this by having n plus 1 over 2. And I'll explain what this means by position here. The position of the median number will tell us where in a data set it'll be. So if we had, say, 3 numbers in the data set, it would be 3 plus 1 over 2, which would be 4 on 2, which would equal 2. So it'll be in position 2. And therefore, the median of this data set, assuming that it was actually in order, I'll just rewrite it there, but the median would be 2 in that case. And that gives us a position there, so we're able to pinpoint it. But sometimes it's not quite as easy as that, because the median number, the middle number, is actually halfway between 2 numbers in the data set. So let's say I add another number on here. We go back to our position formula, which tells us where our median is in the data set. We now have 5 over 2. Therefore, the position is 2.5. And as you can see here, there's no middle number. There's 2 on that side, there's 2 on that side. So, that's where our middle number is going to be. It's going to be somewhere between 2 and 3. Now, in order to find this, we just need to take the average of these 2 numbers. So it's 2 plus 3 over 2, which equals 5 over 2, which equals 2.5. Now in this case, our median value is the same as our position value, so don't get too confused with that, but essentially our median is 2.5 because it's in between 2 and 3. And again, we just find what's in the middle there using the mean formula for the 2 numbers either side of the position of the median. Okay, so that's nice and good. We've gone through some of these simple stat concepts. The next one is mode. Let's say we had a data set like this. The mode of this data set would be 3, because it's the most common occurring number. because it's the most common number, we're able to just pick it out and say, okay, if this was a piece of information, it could possibly be the number of people who, a number of television sets a family owns perhaps. Then we can say that the most common amount of TV sets that a family owns would be 3. That's an example of a statistic we could get from the mode. So there's mean, median, and mode. Now the next key concept is going to be population. And population is simply the group that a statistic concerns. So example, if the ABS was doing a survey, the Australian Bureau of Statistics, then their population would of course be Australia. However, they may not be able to, of course, take sample information from everyone in Australia, because that would be roughly 24.2 million people, and they may need to get statistical data processed very quickly. So if that's the case, what they do is they take a sample. And what constitutes a good sample is if everyone in Australia has a non-zero chance of being picked. And I'll explain what that means now. So population is Australia because the Australian Bureau of Statistics are concerned with Australians. But again, sometimes you can't survey your entire population, so you need to take a sample, a subsection of people who suit your population. Now, if this survey was perhaps biased, then they may actually pick certain people who have the desired characteristics that they want to put into a statistic. Now, I'm not saying that the Australian Bureau of Statistics do this, because they probably don't. But in order to constitute a fair sample, a non-biased sample, everyone in Australia should have the opportunity of being picked. It would be, to some degree, not a random sample, so a biased sample, if they were to just say, okay, we'll pick out of these 200 people, we'll pick 100 out of them. And they need to be able to pick people out of the entire Australian population for it to be considered a fair test, because otherwise they might pick all the healthy people and then produce a statistic saying Australians are incredibly healthy because they purposely selected out people in their surveys who had a low body mass index, for example. And that's an interesting thing to point out. So we covered a few key concepts there. We covered a population, which is the entire group, a sample, which is a subsection of the group, a random sample, which is where everyone has a non-zero chance of being picked, so there's no sort of blocking people out and perhaps skewing any statistical data. And we've also sort of touched briefly upon bias there, because of course bias can mean all the difference with statistics. If you maybe go to a club of people who love the colour yellow, and you ask them what your favourite colour, what their favourite colour was, and they all said yellow, of course, then it probably wouldn't be a really good representation of, say, a town or the entire population you're looking at. So it's very important that you get samples that actually reflect, to some degree, that don't reflect bias, that don't purposely pick out individuals who will give a response that's desired by perhaps a corporation or a statistical company. Because of course they need to be true in their representation and they need to pick suitably from the population. Okay, so now what we're probably going to go on to is we're probably going to look at inferential and descriptive statistics. But before that, I'll just touch up on the concept of outliers. Now, I'll just finish outliers here as being the last part of this video because we're running out of time. But outliers, if we draw a normal distribution, which you've probably seen before, if you haven't, then I'll go through it obviously in a later video, but the outliers are the values on the end. They give extremely different values. So say we took the average number of people in a household and we found 1, 1, 2, 3, and 17, then 17 would be a significant outlier from that data set. I mean, you'd probably want to survey more households than that to get a good sample and constitute a good sample, but of course, that you can see that that would be an outlier because it's incredibly different to all the other values. So that's all for now. See you in the next video.